Alright, time for another DraftPhysics.com, debatephysics.com also. Video presentation number 6 in the series. The final video, we'll just say, of this Al-Khalili atom stuff. Apparently you're not that interested, as the view numbers aren't very good, but who cares? I think it's all important stuff. So, yeah, on with the show and such. So we're halfway through the third video, and he's going to start talking about Feynman pretty soon. I think he's finishing up on Dirac and the fact that there's a bunch of particles, you know, whatever, poofing into existence, annihilating, poofing out, poofing in, bunch of poofy. At least there's no music.
Down at the smaller scale, space is a constant storm of creation and destruction. Physicists call it the quantum foam. The particles in the quantum foam come and go so quickly that we're completely unaware of them. We refer to them as virtual particles. But if we were able to...
Sorry, virtual particle. That's just, you know, I mean, I'm calling it a fable, and he basically just said fable particles. You know, they can't make them real because they can't account for their existence. That's why they have to call them virtual. I mean, it's just such garbage.
Slow time down, almost to a standstill, we'd be able to see this seeding activity, this constant creation and annihilation of matter and energy that's the fabric of reality itself. And from this comes the most jaw-dropping idea of all.
Oh, so that wasn't enough.
Quantum electrodynamics says that the matter we think of as the stuff that makes up the everyday world.
Right, so there's these bits of matter, the electron, proton, you have to account for them. They don't have little jet engines. They have to be pushed if they're going to go somewhere. You know, it's just so obvious. The force pushes the matter, and you have to conserve the force. Can't annihilate it, ever.
The world that we see and feel is basically just a kind of leftover from all the feverish activity that virtual particles get up to in the...
I mean, you know, so, you know, it's just breaking all accountability, you know, in terms of any notions of conservation. Just crap.
Void. So you, me, the earth, the stars, everything is basically just a part of a deeper, infinitely more complex reality.
So again, it's just, they're just trying to rewrite a religion, a new god. Quantum. Just not a great name, right? I am that I am. It's probably better than this.
Of course, when Feynman first started to develop his revolutionary ideas in Caltech in the mid-40s...
So there's nothing, he didn't invent anything revolutionary. He found a shortcut way of doing math, and that's about it. And his other crap with this crap involving borrowing energy from the future, as long as you pay it back, too ridiculous. I mean, even he didn't take that seriously.
His contemporaries were horrified, because at that time the general opinion was that the quantum electrodynamics project was an unmitigated disaster. The theory couldn't be solved. The equations had no sensible solutions. The mathematics had spiraled out of control.
So this is, so you know, he's just very deceptive. And so what they basically did was just say, well, let's just pretend those problems don't exist. That's called normalization. So they just took the boundaries and just narrowed the boundaries to some middle section where there weren't any errors. So that's all they did. They just said, let's pretend it doesn't fail, when, yeah, it does. You drive over 50 miles an hour, the car blows up. Okay, so just don't drive over 50 miles an hour. That's what they basically said.
But Feynman believed that he could see a way through the mathematical complexity to a new truth. What Feynman did, with all the arrogance and confidence of youth, was slash through the insanely complicated maths. Feynman developed a new series of revolutionary but almost childlike diagrams to explain his new ideas. Their elegant simplicity flew in the face of the complex maths of traditional quantum mechanics.
I mean, obviously it's better to draw this stuff, in my opinion, And it really is some sort of like conservational stuff. But this idea that somehow a single electron creates a single photon and all that, it's not accurate. So yeah, it's fine if you're going to describe a system, but it sucks at describing individual particles.
Conflict seemed inevitable. Then, in 1948, at the age of 30, Richard Feynman decided to unveil his controversial version of quantum electrodynamics with his idiosyncratic diagrams to the physics world. And he chose the most important science conference of the American calendar. Set on the coast of Pennsylvania, the Shelter Island Conference was a physics celebrity circus.
So it is interesting that when he gave his 2 sets of specialty lectures that they videoed, none of that was in those lectures. Okay.
Present were Niels Bohr, the so-called father of atomic physics, the discoverer of antimatter, Paul Dirac, and the man behind America's atom bomb, Robert Oppenheimer. The atmosphere at the start of the conference was grim. Confidence in quantum electrodynamics was at rock bottom. It seemed a hopeless mess. One after another.
Let's just understand, it's based on this is where Feynman comes up with the line, shut up and calculate. It's, it really is disconnected from the physical reality, and it's just making assumptions about reality that just aren't true, that somehow things can be randomized. And they aren't randomized. They will fill in probabilities, but it's like flipping coins. If I throw, things, let's say even red and blue things at a wall, there's a certain odds of a red hitting the wall and a blue thing next to each other. And when that happens, you could say that's a photon. And you could write up a probability for it. And you might even end up with a pattern that ended up being sequential, if you throw enough of them.
The physicists stood up and droned on despairingly about how they'd failed to find a solution. Then it was the turn of Richard Feynman. Barely 30 years old, he stood up and took his place in front of the world's most illustrious scientists and started to unveil his new diagrams and equations. What happened next was astonishing. A row broke out, not so much over Feynman's weird description of reality. Physicists were used to weird by now. But because he dared to visualize what was going on. Instead of using arcane...
So that's, this is sort of a giveaway to the fact that, yes, this is why Einstein was alienated. His physics wasn't about anything physical anymore. It was about unimaginable, sparkly unicorn fluff.
Complicated mathematics, Feynman was describing what all his virtual particles were up to using his simple pictures. There was uproar. Niels Bohr, the father of quantum mechanics, leapt from his chair in disgust. He hated Feynman's diagrams because they went completely against everything he devoted his whole life to. You see, he believed that atomic particles could not be visualized under any circumstances.
Misunderstanding. Feynman's calling them virtual. So, it's just such a joke. He doesn't like the ghost particles because they're not ghostly enough. You can't draw a picture of the ghost. That's verboten.
Feynman defended his new theory, trying to explain that the diagrams were simply a tool to help visualize his new equations. But the rest of the scientists, including Paul Dirac, wouldn't hear of it. They called him an idiot who understood nothing about quantum mechanics.
Look, okay, he's obviously not an idiot, but he doesn't really have a deep understanding, of these fundamental concepts, and you can see that in his drawings. So go watch his presentation of the double slit experiment, and you'll just see somebody has no clue what the actual patterns are and what the actual fringe patterns do.
Feynman ended his lecture bruised but unrepentant. He knew that his diagrams and equations were correct, if only he could convince the others.
And again, in all of the Feynman lectures, what is a reoccurring theme in the 2 examples, he uses different things in the 2 different lectures 20 years apart, lenses and layers of glass. And all of them have that common theme of recognizing that everything comes in clumps, in the sense that it's a in phase, out of phase, in phase, out of phase. And that the atoms themselves are clumps. And if you're going to push something into a surface, you're going to see it. Okay, every time the clock hits 12, that means the size of an atom, the size of an atom, the size of an atom.
That evening, Feynman met another young physicist called Julian Schwinger. Now, Schwinger was the same age as Feynman and had been identified as a child prodigy at the age of 12. Although he and Feynman had been working independently and had approached the problem of quantum electrodynamics very differently, they'd reached identical conclusions.
So we don't know any of that for sure, but they both got the Nobel Prize. They had to share it. So again, it's another one of these coincidences. I don't like coincidences.
With their new equations, they could solve quantum electrodynamics, and with Feynman's diagrams, they produced a theory of awesome power. Together now is...
So this is where the hype comes in. This awesome power to do what? What did it do? What did it invent?
Allies, they planned a full frontal attack on Niels Bohr and the Conservatives. By the end of the conference, the mood in the Pennsylvanian roadhouse had changed from one of frustrated hopelessness to one of excitement and idealism. Over the next few years, their theory was fleshed out and rapidly became the most accurate and powerful...
So this is the hype. Accurate and powerful at what? At creating a pattern that doesn't exist, that the experiment doesn't actually produce. Yeah. Sorry, no sale.
Theory mankind had ever had.
I mean, it's just such a preposterous lie. So what they always keep talking about is this stupid magnetron thing that measures a deflection in an electron or a proton, and they have a calculation that parallels what the device is doing, and they're saying they have the most predictive, accurate theory in the history of mankind because their theoretical numbers start to match better and better with their experiment. As they improve the machine, it more accurately reflects the numbers they're looking for. I mean, there's just nothing here. This is just such hype.
Despite finally being tamed, quantum electrodynamics talk of empty space seething with energy we can't feel and virtual particles we can't see.
Right, so just, it's not physics, okay? This is religion. This is just, he's just going to tell us ghost stories. Virtual particles and energy that's not energy, because it can't do any work. What's the point?
It does make many people, including physicists, a little suspicious. And many skeptics...
There's just no evidence of it, because you don't even talk about it. Nobody will debate it, no one will argue it, nobody will do any of it. You just all preach it. You don't argue it. You don't talk about how, well, shit, shouldn't we wait for a better answer than this ghost particle crap?
Might say these ghostly objects that allegedly fill the vacuum aren't actually real. Yes, the complicated mathematical equations of quantum electrodynamics seem to require them, but that doesn't...
So again, require them to satisfy what? A complex, arbitrary, contrived formula that doesn't have any, that has such a loose connection to anything real. It's just amazing that this is what they allowed physics, the science of physics, to turn into.
Itself mean they exist. They might just be mathematical fantasies with no basis in reality.
You know, frankly, I'd bet my life on the fact that that's exactly the truth. That's how confident I am this is horseshit. And I wonder how much they would invest in this. You know, if I'm holding a butcher's knife over their hand, you know, and, you know, it's all, you know, your hand comes off if this is bullshit. I wonder if they'd keep their hand on the chopping block or beg to differ and say, well, yeah, I'm not really that sure.
Well, I have bad news for the skeptics. Since the late 1950s, direct evidence that empty space...
So this is coming from a guy who thinks it's direct evidence of what a two-slit experiment does when you shoot an electron into a flat piece of nickel. That's the same thing as shooting it through two slits. Same thing. It's identical. So, yeah, how much can you trust this guy? I wouldn't trust him.
Isn't in the slightest bit empty, but is in fact seething with activity. has been observed.
Well, we all know, I'm just saying there's no possibility of having a theory that doesn't include that, because we know that cell phone calls right now are flying through us, and microwaves, cosmic energy from, in different forms. All kinds of stuff is hitting us all the time, so we know space is full of a bunch of noise. That's not an issue. The fact that you're saying it's poofing into existence, that's an issue.
Time and time again in laboratories. Quantum electrodynamics is by any measure a truly magnificent discovery.
It's just bullshit. I mean, it's just an amazing statement. This thing that does absolutely nothing, it calculates nothing, it predicts nothing, it controls nothing, it does nothing. And they just hype this crap because it has woocles in it. It proves the existence of woocles. Without this formula, they can't claim woocles exist or something. And so they just keep hyping it like this pumps up your bicycle tires or something. It doesn't do shit.
It's one great pinnacle of our story. A glorious...
Oh, I believe I forgot to block the image. Yes, well, I'll have to do it, and I'll have to edit the video. Shit.
Conclusion to 5 amazing decades of science. In quantum electrodynamics, the atom had given us a theory that explains much of our universe with stunning accuracy. But since quantum electrodynamics...
It's all hype. I mean, why am I even listening to this shit? Might as well get rid of the camera, because it's not really doing anything, right? That's probably the wrong one. Yeah, that's the wrong one. Where's the other camera? This one here. I don't need that. Yeah, I like that better. Continuing, I mean, just hype. It just doesn't do anything but hype.
Triumphant arrival in the late 40s, our story becomes rather messy and awkward. As a result of quantum electrodynamics, scientists were convinced that the vast majority of everything in the universe consisted of essentially just 2 things: atoms and light. Light was made out of time.
So that statement is just so fucking correct. And yet all this, then why are you talking about all these gluons and buons and puons and zooons and all this other crap and blah, 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 and all these quirky crap and all this other crap? Why bother with any of that crap? Because you can explain it as force and matter. The interaction between force that doesn't interact with force and matter provides the force a conduit, a catalyst that allows the force to push on itself.
Tiny particles called photons. And atoms were made out of 3 components.
So the photons are not photons, okay? They're not a round ball called a photon. A photon is a frequency. It's a frequency of energy quanta, as I think Einstein said. He said energy quanta. I mean, he just wasn't very explicit, okay? So, and he didn't draw a picture of a photon, so... but a photon is not some stretching balloon that gets bigger and smaller depending what frequency it is. It's a frequency of events.
The electron, the proton, and the neutron. And because of antimatter, it was...
Right enough. They just stopped right there. So why you just said this is all they thought, needed to exist, and then you bring up this antimatter stuff that just makes a mess out of the story. Because you really can't make it compatible, so why bother with it?
Antiprotons, antineutrons, and positrons. A bit strange, but pleasingly symmetrical.
There's no symmetry, okay? The photons affect electrons. If I make the negative things into big, heavy, negative balls, I have a completely different interaction. So every time a photon flies through space, it's going to affect antimatter different than it's going to affect regular matter, because the wrong objects, the wrong polarity of object is going to be on the outside of the nucleus. Going to make a difference. The photons interact with electrons. They don't interact with protons.
Everything in the physics garden was rosy, thanks to the rules of quantum electrodynamics. But then, much to the profound irritation of every working physicist, a load of new and exotic particles suddenly appeared like party gatecrashers to spoil the fun.
Now, none of them appeared anywhere. They're all projections. So they see something happen. So they have a cloud chamber, and all of a sudden, a little spot lights up and a ray flies out. Now they have to say, okay, something happened. Something must have hit that little spot and cause this proton or electron to be ejected. So it's the invisible part they're telling you they saw or they discovered, when obviously the invisible part isn't anything they can see. So they just make up what it is. That's why they can't show you a picture of a quark, because the quark never showed itself. All they saw was something happened, and they blamed the quark.
Exotic entities that didn't fit into any known theories were appearing in physics labs with such frequency that scientists couldn't keep up with naming them all.
Yeah, they were so busy naming them, they didn't take any time to think about, well, maybe there's another explanation. Maybe there's another explanation. Let's maybe spend a couple of days thinking about it. You know, so all these other subjects, gravitational lensing, nobody could figure out that the lens is the wrong shape? And that's pretty significant, considering that the object you're lensing might be 100,000 light years across, and therefore the photons have to both be bent exactly the same amount for you to see an image. I mean, none of them think about that and say, well, yeah, gee, that really doesn't work, does it?
Neutrino, the positive pion, the negative pion, the kaon, the lambda, the delta.
So none of these things are actually seen, okay? They're just presumed based on the fact that they saw a photon in a scintillator. So they said, wow, that's got to be a muon.
And of course, each of these had their antimatter counterparts. When one new particle named the muon was discovered, one physicist quipped, "Who ordered that?" The whole thing was a mess that didn't make sense. And physicists despairingly referred to it as the...
This is just energy, right? So the fact is you can have an electron going 10 miles an hour, or you can have an electron going 2 million miles an hour, or 2.8 million miles an hour. Any one of those ranges, any one of those is a possibility. And the fact is they're basically saying, because it has a certain amount of energy, we're going to give it a different name. And that's stupid.
Particle zoo. It began to seem as though every time scientists solved one of nature's mysteries, the atom would present them with something even more weird. Within just a few years, atomic physics had gone from a position of quiet confidence to total chaos.
So how could there be any, quiet confidence when they're talking about positrons? And that really didn't happen. So let's understand, they didn't discover this positron until much later.
And of course, to make some sense of this new mystery would require, yes, you've guessed it.
And let's understand, they didn't discover it, they just named it.
Another scientific revolution. The third genius in our story is Murray Gell-Mann. Gell-Mann was a child prodigy. By the age of 15, he'd already started at Yale to study physics and had finished his PhD by his early 20s. He had an incredible intelligence that terrified those around him. He spoke many languages and seemed to have this deep knowledge of any subject you care to throw at him. Like Richard Feynman, whom he joined here at Caltech in the early 60s, he seemed to have this ability to see beyond the mathematics and the formalism of his theories to the underlying secrets of nature below.
Well, it's clear that he didn't really have any kind of... he wasn't making much of a contribution because, frankly, I mean, compared to Feynman, he's almost an unknown character. And I've seen him interviewed, but I can't remember anything he even said. Again, I'm confused with the other guy. It's kind of heavy set also.
Together, Gell-Mann and Feynman made an awesome duo. This office, number 456, used to belong to Feynman. But what's great is that just 2 doors along the corridor was the office of Murray Gell-Mann. There was an intense academic rivalry between these 2 intellectual giants, but they fed off each other's creativity. They were very...
So it's all just math crap, and there really wasn't any physics. Nothing physical, nothing real, just abstract mush.
Different personalities. Feynman, who played the buffoon, Gell-Mann, the cultured elitist. Gell-Mann used to get upset by Feynman's loud voice, and Feynman certainly enjoyed winding him up. But it's fair to say that during the 1960s and 70s, these 2 geniuses here at Caltech dominated the world of particle physics.
Right, so it's all controlled by this nonsense, okay? So a couple of these, they have some bishop meeting, and they send some smoke signals up the pipe and decide, what's going to be believed by everybody now. What's the new religion say? We wrote in the holy book some new silly sentence. Like the second law of thermodynamics, that's completely idiotic. I mean, there's just no evidence that the universe is falling into disorder because every millisecond it's crushing matter into little balls. Shit. I mean, how could it be more obvious? I mean, there's so, the strong force, again, they couldn't think that, well, I have two protons that are far apart. How do I get them close together? Well, you stick an electron between them and they'll go right together. No problem. They couldn't think of that?
Their bitter rivalry pushed them both to the very limits of their imaginations. And Gell-Mann especially was desperate to prove himself over Feynman by bringing some order into the particle zoo. Within the feverishly intellectual atmosphere of Caltech, Gell-Mann's mind did something very strange. He started working with a different kind of mathematics to deal with the preponderance of subatomic particles. He used an obscure form of maths called group theory. As its name suggests, this is a theory that analyzes groups of numbers and symbols and tries to organize them.
Right, so just decide to, this is like looking at something through a prism or something. You're just trying to, and then you try to say, well, I can make a square out of a circle. So?
Them into simple patterns and symmetries. It's a bit like working with an abstract form of origami. Using this technique, Gell-Mann started working all known particles into an organized system.
Right, so he says he calls it organized, and there's just nothing organized about it. All you know is there's certain features that stuff has. Charge is the obvious one, right? And, then they invented spin, which is some relation to polarization, but not really, because frankly, I think we know electrons aren't polarized.
Which he called the Eightfold Way, after a Buddhist poem. But then he had his most awesome revelation. Gell-Mann realized that his group theory pointed to a new, deeper underlying mathematical truth, something which had the potential of rewriting the atomic rulebook.
Mush.
What Gell-Mann's mathematics revealed to him was that in order to make coherent patterns of all the new particles in his Eightfold Way, he had to acknowledge that there was a deeper underlying fundamental reality. Once again, it turned out that things were not at all as they seemed.
All right, so again, it's just a rejection of the nice, simple, rational model. So like Newton, momentum worked, it all made sense, and they didn't quite understand that heat was movement still momentum. Little things moving is the same as big things moving. Same amount of energy required by mass. And then it was all circular and conservative. And here we had a simple model of electrons, protons, creating charge. The idea that the neutron was somehow, I don't know when they figured it out, that they decay into electrons and protons. But that's why it's neutral. It has both. So up close, it's a magnet. Far away, it's just a neutral particle.
You see, physicists have been comfortable with the notion that atoms are made up of three different kinds of particles. Electrons orbiting around the outside of a nucleus.
So the orbiting crap is just that crap. There's no need for them to orbit. They can be in fixed geometric positions, just like magnets. If I take a bunch of magnets and put them between a piece of glass with all their little north sides in one condition, and I put a positive south side in the middle, I can arrange them so they'll all stay in those positions because they can't flip.
Itself made up of protons and neutrons. Gell-Mann had the temerity to suggest that protons and neutrons were themselves composed of more elementary particles. Particles that he called quarks.
Right, crap. Crap. So again, they're never seen. They're just some thing they say caused an effect. So just like a hunk of gamma rays could be causing the effect, a piece of photons could be causing the effect. Lots of things could be causing the effect. But they're going to say, oh no, it was these quirky things.
Murray Gell-Mann was cultured and arrogant, but at heart lacked confidence. He knew that for his colleagues, even those used to the strangeness of the atom, quarks were a step too far.
So this is the same as the story of the positron, right? So they do experiments, they see the same thing. Before somebody decides Dirac was right, they're all protons. All of a sudden, when Dirac is right, now it's a positron. Same thing here. Crap they probably saw before, now they're just going to call it quarky dust. A quark event.
And in any case, there'd been no evidence of anything remotely like a quark. He was convinced his new theory would be declared outlandish, or just wrong. So Gell-Mann sat on his revelation, and one of the greatest ideas in science was almost lost forever.
Oh, jeez, it's just amazing. Amazing. They can't show you this damn thing. And yet they're going to claim they absolutely know it's real.
Then something extraordinary turned up just a few hundred miles north of his office. This is the Stanford Linear Accelerator, a few miles south of San Francisco. What you can see below me is one end of what is basically a giant electron gun. A beam of high-energy electrons.
So it's not an electron gun because, you know, these accelerators have to keep pushing the electrons. They don't keep going.
Is fired through a tunnel that starts off over 2 miles away in the hills, travels underneath the freeway, and comes out at this end where it enters the experimental area. The grey building over there is called End Station A, and is where one of the most important discoveries in physics was made. It was built during the 1960s, when it was, and still is today, the longest single building on Earth. And although it's 40 years old, you can see a lot of construction work is going on now. It's still being used for fundamental research today.
I can't see much, sorry.
I'm now inside the 2-mile-long linear accelerator building. The red objects you see on your right are called klystrons, and they provide the power that boosts the electron beam that runs 20 feet beneath us. Such is the acceleration, these electrons will, within the first few meters, have reached 99% the speed of light. Let me put it another way.
So it's all kind of, you know, all of this is kind of debatable about what the hell's going, what kind of beam is actually traveling through there, and how much the electrons are moving versus all the other rays that you're using to push them. So you're pushing them with a bunch of high energy photons, and you know, you're going to hit the target with a lot of high energy photons.
If these electrons were to start off their journey at the same time that you fire a bullet from a gun, they will have covered the full 2-mile distance before the bullet has even left the barrel.
Yes, the speed of light is fast.
The electron beam, now travelling at almost the speed of light, would have arrived here at the target area. There would have been in 1968, where I'm standing now, a large tank of hydrogen, basically protons. The electrons would smash into the protons and scatter off through tubes to be picked up by huge detectors that filled the hall outside. And as they did this, physicists got their biggest ever confirmation that there might be a deeper set of rules underpinning the particle zoo.
So this is after it's traveled through some tubes. These are now the protons that have been hit by electrons, and now they're going to scatter into something else and cause some more fragments.
What they had discovered, from the way the electrons scattered and because of their extremely high energy, was conclusive proof that protons...
So again, conclusive proof. It's just such an outrageous thing to do, to say this is conclusive. It's not at all conclusive. Again, you can't show us anything saying where show me the conclusive proof. All right, all you did is demonstrate that, yeah, you hit things that are moving very fast into things not moving very fast, and they all fly apart like a bunch of pool balls. And what else did you show?
Have internal structure. In other words, protons were themselves made of more elementary particles. Here were Gell-Mann's quarks.
Right, so there's no reason to believe that's true. So it's just pieces of force pushing on whatever you're using in this material to create some more scatter that you can see. And that's all there is. This is, again, you're hitting molecules of some kind of cloud chamber substance. And you don't know what you hit them with.
This was an astonishing moment. For decades, people were confident that the components of the atomic nucleus, the proton and neutron, were absolutely fundamental.
Well, obviously the neutron wasn't fundamental, so I don't know why they would have assumed that.
And now, for the first time, there was evidence of something deeper. The quark is a tricky and elusive beast. There are 6 different kinds,
So there was 3, and then they made it 6.
or flavours of quark. Up, down, strange, charm, top and bottom. Also, quarks never exist in isolation, only in combination with other quarks.
So that doesn't even mean, what does that even mean? I mean, you have to have a pair of quarks to cause an effect. I mean, so then you're back to 3 again.
This makes them impossible to see directly. We can only infer their presence.
See? So it's absolute proof. Our inferences are absolute proof. No way you can get around it. When we inference, that's proof.
But despite these caveats, the quark brought some semblance of order to the particle zoo. In recent years, it's allowed us to concoct a simple yet powerful
So at least that's the
description
right word, concoct. This is all just bullshit.
of how the universe is built up. Basically, everything in the universe made of atoms is built up from just quarks and electrons. That's it. This now brings us pretty well right.
So it just makes a mess out of something kind of logical. Obviously the proton has charge, a charge that's exactly the opposite of the proton and the electron have exactly opposite features of the same intensity. It just breaks all continuity to start talking about how the proton is this much more complicated organism, but yet it behaves exactly like the electron in inverse. So the same force affects the two in exactly an opposite manner. The electron is pulled by the same force, the proton is pushed, and vice versa. I mean, bullshit. They're dysfunctionally different.
Right up to date. The discovery of the quark in 1967 was the last significant experimental discovery of a new type of fundamental particle. Some say we may yet discover that quark is made of something even stranger, and it's...
Where are they going? It's just such bullshit. Why don't you find the infinitum, the infinity particle?
possible. But for now, it's as good as it gets. Our journey from Einstein's proof of the existence of atoms in 1905 until now has been extraordinary. We've learned so much about the atomic world.
So again, they've made up a silly story when we already knew, Newton already knew, Maxwell certainly did in some respects know there's this fundamental feature, charge, and it's fundamentally related to magnetism. That I don't know why they never concluded that the electron and proton are obviously the magnetic monopoles. Obviously. They're not only electrical monopoles, they're magnetic monopoles.
From the size and shape of the atom to how its center holds the secret of the universe itself. From how it reveals an unknown world of antimatter to how empty space is far from empty. From what we thought was a basic building block of the universe itself to the discovery of something even more fundamental inside it. And yet,
So it's not fundamental, it's fundamentally nonsense. It's bullshit. It breaks continuity. It doesn't create continuity.
despite all the powerful science which we've uncovered, something doesn't quite add up.
Well, he always does this. It's the most proven theory in the history of mankind. Well, yeah, except for the part that doesn't work. But it's most proven. Except for the part that's not proven very much.
There are two startling and worrying anomalies. The first of these is now at the forefront of theoretical physics across the world, and it concerns one of the oldest scientific principles there is: gravity. Now, though gravity has been thoroughly understood since Einstein...
So that's frightening, okay? Thoroughly understood since Einstein. Yeah, just, again, when nobody understood and nobody could even figure out why. Again, it's pretty hard for me to figure out why is bending photons necessary to relativity? You know, or explaining Mercury's precession. Why do I need to bend photons? What does that have to do with anything?
Never really been part of atomic theory until now. Suddenly, there's a glimmer of hope from ideas that sound almost too crazy to be possible.
Compared to what? Gluons?
Of these are called string theories.
Oh, so, you know, why does he even bring this up when, you know, it doesn't work? Fact.
That regard all subatomic particles as tiny vibrating strings that have higher dimensions of space trapped inside them.
Oh, I mean, it's just, Jesus Christ. I can't believe I have to argue this. This baby, this is just blah, 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 blah.
Some, called brain theories, suggest that our entire space and time is just a membrane floating through the multiverse.
So, you know, some. And then some of us, you know, we actually shoot up drugs. You know. What? You know.
Another, called quantum loop gravity, suggests that nothing really exists at all, and that everything is ultimately...
Why do you people defend this shit?
...made up of tiny loops in space and time themselves. But despite...
It all has to be loop-de-doo and poofty-woofty and, you know, wavy-wavy and all this bullshit. God, it is so... Ugh. Pink tutu physics.
His unwillingness to fit in with quantum theory, I believe there's something worse lurking in the quantum shadows. Something truly nightmarish. Late into the night at physics conferences all over the world, over drinks at the bar.
Yeah, exactly. You people must drink a lot. Yeah, fuck.
When we scientists huddle together to debate and discuss our strangest ideas and dreams.
Why don't you do this in public? I mean, why don't you let us in on it?
There are still things that really, really bother us. And chief among these are the quantum mechanical laws that atoms obey. And in particular, one aspect of these laws, something called the measurement problem. If you want to see fear in a quantum physicist's eyes, just mention the words, the measurement problem.
All right, so there is no measurement problem. The problem is that the idea of examining something when we do it, and versus when the universe itself does it. So, like, yes, if we're going to see something, we have to put a magnifying glass and look. But the fact is this doesn't change anything. It's still just receiving photons that hit the surface, and we put them up against our eye and see them. They're still going everywhere else. They're everywhere. The photons are everywhere. The thing is being measured already. It doesn't matter whether I put a magnifying glass up against my eye and look. It's the same things hitting the surface. Nothing's changed. It's not about film and the camera. It's the fact is that everything is constantly being bombarded. You just said it. Space is full of energy, full of stuff happening. Nothing is ever unmeasured. Everything is constantly affecting everything else. Everything is irradiating energy constantly. Any motion, your heart beating, it's actually traveling, okay? If somebody has a good enough sound detector, they can hear my heart beating from, 50 feet away. I mean, this is the bullshit of this, is that there's no measurement problem because there's no such thing as anything in space that isn't being measured. It's always being measured. It can never escape being measured.
The measurement problem is this. An atom only appears in a particular place if you measure it. In other words, an atom is spread out all over the place until a conscious observer decides...
So we know that's just not true. It doesn't have anything to do with a conscious fucking observer, okay? He doesn't make any difference at all. The fact is the atom can never be in this universe and not be bombarded by energy. And that energy reflects off of it, and that's an image of it in space. And all you have to do is put the film here and you can see it. But the fact is it's too damn small to look at it. So, you know, all there's, again, this is just such bullshit. This Heisenberg nonsense.
to look at it. So the act of measurement or observation creates the entire universe. And just to show you how mad this idea is, I'm going to explain one of the most famous hypothetical experiments in the whole of...
Why would he even do this Dr. Quantum crap of even implying that our observations are somehow different than the universe's observations, or that somehow a conscious brain has to look at something or it doesn't exist? I mean, why would he even indulge in that crap?
Science.
Physicists, generally speaking, don't believe that, okay? They really don't think a conscious observer has to look at it like a dog or a cat or a human. They know that anything shooting photons at it is already looking at it. As soon as the photons hit it, it's been measured.
It's called the Schrodinger's cat experiment.
So the joke is Schrodinger contrived this fucking goddamn thing to make fun of quantum mechanics. It's a joke. It's to point out how ludicrous this crap is. Shit. So we know that if the box is a superficial block, it blocks our eyesight from seeing in the block in the box. It doesn't block infrared radiation. It doesn't block a lot of other kinds of radiation, X-rays, lots of stuff. So this is all just bullshit. And it also isn't going to change the fact that if the cat's alive, it's creating heat. And it's going to heat the air in the box if we just have a thermometer in there and we know the cat's alive. Lots of ways to detect it. But the fact is gravity and all kinds of forces are going right through that box. And it's just absolute nonsense to talk about how that cat can be in some superposition. It can't be, ever. Because it's constantly being hit by atoms, it's constantly being hit by forces.
Erwin Schrödinger was one of the founding fathers of atomic theory, and in the mid-1930s...
He hated quantum mechanics, your interpretation of it, fact. And he tried to make fun of it, it's so silly. Fact.
Devised a thought experiment purely to highlight the absurdity of quantum mechanics. He suggested you take a box in which you place an unopened container of cyanide connected to a radiation detector and some radioactive material. Now, the idea is that if an atom in the material emits a particle, this will be picked up by the detector, which in turn releases the cyanide. Next, you take Schrödinger's cat, which in this case is a lovely Norwegian forest cat called Dawkins. Now, I should point out that this isn't real cyanide. You place the cat in the box, you close the lid, and wait. So here's the conundrum. According to traditional quantum mechanics, known as the Copenhagen interpretation...
Nonsense. I mean, I don't even know why... I don't even think the Copenhagen interpretation originally said anything about this crap. But anyway, that's what it became when they decided to defend entanglement.
All the time the box is closed, the radioactive atom inside has yet to make up its mind whether it has decayed and spat out a particle.
So this is the silly part, made up its mind? What the fuck does any of this have to do with it? We know there's a certain probability of it happening, and that's it.
So we have to describe it as both having decayed and not decayed at the same time.
Why do we have to do that? Oh, that's right, no reason. So again, this is all based on the two-slit experiment, which I've explained doesn't have anything to do with waves, and doesn't have anything to do with photons going through both slits or any of that horse shit. There is no superposition, and there is no entanglement, and there is no destructive interference.
This means, since the radioactive particle triggers the release of the poison, the cat is both poisoned and not poisoned. So until we open the lid to check up on the fate of the cat, what's called making a measurement, it's not just that we don't know, but that the cat is literally both dead and alive at the same time.
Right, so it is ludicrous. The joke, it worked. You're idiots. You're insane fucking kooks. How the fuck could you believe this has anything to do with reality? It's like I could put an 8 timer in instead of the radioactive thing, and so I know exactly when the radioactive piece of crap is going to hit the cat. You know, the poison's going to be broken. Because I know it doesn't happen, or the cat doesn't do the same bullshit you're talking about because one person knows when the timer's going to go off. I mean, the whole thing is ridiculous.
This is clearly a paradox. Or is it?
It's clearly nonsense.
The paradox of Schrodinger's cat and the contradictory nature of their measurement problem really does force us to accept that tiny objects down at the atomic scale obey their...
We're forced to accept this bullshit, just made up, phantasmagorical nonsense. Shit.
...own set of profoundly strange rules. But at larger scales, those of everyday human experience, those rules vanish, and an utterly new set of nice, intuitive rules take over. How can...
Oh, how convenient. The ghosts are really, really tiny and we can't see them, but the ghosts exist.
This be? Some argue that in fact, the quantum weirdness of the atom might actually be writ large across the cosmos. That we may have to rethink everything we knew about the universe. In the last 100 years, we have peered deep inside the atom, the basic building block of the universe. And inside this tiny object, we have found a strange new world, governed by exotic laws that at times seem to defy reason. Atoms present us with dizzying contradictions. They can behave both as particles or waves. They appear to be...
So the big lie, okay, so there's no waves, it doesn't happen. They're real carriers of momentum, photons, that's what they are, little pieces of momentum, and they stick to electrons and protons and give them momentum.
In more than one place at the same time. They force us to rethink what we mean by past and future, by cause and effect. And they tell us strange things about where the universe came from and where it's going. Pretty amazing stuff for something that's just a millionth of a millimeter across.
Just a religion.
That's why Niels Bohr, the father of atomic physics, once said that when it comes to atoms, language can only be used as poetry.
So that's physics, that's a science, poetry. Puke.
What's fascinating to me is that although we've learnt an incredible amount about atoms and their behaviour, our scientific journey has only just...
So, again, he said all that proof crap, so let's just put this in context. He said the word proof about 17 times in the video.
...begun. Because although we know how a single atom, or just a few atoms, behave, the way trillions of them come together in concert to create the world around us is still largely a mystery.
So that's almost backwards, right? I mean, the big things aren't mysterious.
To give you one dramatic example, the atoms that make up my body are identical to the atoms in the rocks, the trees, the air, even the stars. And yet they come together to create a conscious being.
Oh, so that's it. You're going to pretend that your consciousness isn't something other than just a projection created by your brain. It's a delusion. It's one hell of a delusion, but that's all it is.
Who can ask the question, what is an atom? Explaining all that is surely the next great challenge in science.
No, it's just a waste of time. I mean, it's a mechanical process. We already know what it's made out of. Brain tissue, billions of cells storing bits of information and constructing the world we perceive. Okay, we sense it because our brain creates a sense of it. Jeez. Alright, so that was just so bad. Oh, God. Horrible. Alright, so at least we're done with it. So I can move on to other assholes. So, till then, and such, and so forth and whatnot. Oh, yeah, just an hour. Okay.